Welcome back. So now in this session we focus on demos. So whatever we have studied in the last session, so we'll try to analyze through the code. Hope the screen is visible. So simple CNN using Keras. So first, similar to any language, so we need to import all the necessary APIs or the functions. So here we are developing a sequential model. So we have both sequential and functional model. We are using sequential model, sequential CNN. So CNN consists of conv 2D followed by the dense layers, and we are flattening it to connect the convolution with the dense layers. So for plotting, and we are using the built-in dataset MNIST and to convert the labels to categorical one-hot vectors. So we are using two categorical. Okay, so these are necessary inputs we need. So first we need to import the data. So this data can be a custom data set or the predefined data set. So here we have Keras provides the MNIST data set. Similarly, MNIST, fashion MNIST, so various data sets are available. So we are using MNIST data set. So the data must be arranged in the form of an X string, means the data and the label. Similarly for test also, data and label format. So hope you all have exposure to Google Colab. Okay. So we can visualize what is there in the data sets. So if we try to first element in the train data set, we are trying to plot. Okay. So we can analyze the shape. Okay. So what is the shape of the input? To create width, to create height. Okay. So overall height. So we have so total 60,000 images, which are size from 821. 2828. Okay, so because it's not RGB channel, so we need to reshape the back size, comma, width and height and the channel. Okay, so we are converting that, we are adding the channel, third dimension. So we are converting on the labels into one hot vector. So this is how we define the CNN structure. So it's a sequential model, consists of two convolution layers, and we are using 64 filters, and each of size 3 cross 3, and we are using value as activation function, so which is max of 0 comma x, and the inputs shape is same as this one, 2828 1, and the output from this convolution we are passing to the next layer, and then we are flattening, and it is a 10 class problem, so we have 10 square 10. And we are using softmax, which distributes the probability for each class. And the class which is having highest probability assigned is the label of the image. So this is how the model structure. So total we have 203434 parameters to learn. A simple model. Okay, so now font size.
You can zoom out. Control and scroll.
Okay, so first we need input. Then for demo purpose, we are using the data set which is available through Keras. And so we are, what is the digit, okay, which is the first digit here in the training data set, and we are visualizing. Next, what is the shape of each image and how many images are there in the train. Because it's a two dimension, CNN expects a 3-dimensional image where the 3-dimension is a channel. So we are making it as a one channel, okay, black and white. Okay, so extreme, and this white line we are converting into a one-hot encoding where the class is given label 1, other classes are marked as 0. And here we are defining the model structure by using sequential, which is a combination of two convolution layers. So there is no max pooling or lower average pooling. Okay, then only one dense layer. Again, I need to read. So once we define the model, okay, so we can compile it. Presentation. Same as a code. Yes, that's what's not present.
Right.
You lost your network connection.
ಇದೆಲ್ಲ chat lo, chat lo. Yeah. ಇಲ್ಲ ഇവിടെ ഈ ക്ലാസ് മറ്റേ ക്ലാസ് മറ്റേ നന്നായിട്ട്
I'm sorry, there is a the that connection. So again, we're connecting. Okay. So we have to gradient design. Okay, based upon the once the output is given by model, so we compute categorical cross entry loss. Okay, and that loss, based upon that, we need to update the weights by using backpropagation. So what is the metric we are using? We are using accuracy as a metric. Okay, so once we define the optimizer, that means how we move in the convex optimization space and loss and metrics, then we can train the model. So while training, you need to specify the train data and the corresponding value label. Similarly, just data and the corresponding label. So we are using 3 epochs to train the model. So almost we are able to reach 97% accuracy. So what actually happening in the training is it is trying to understand the correlation between the trained images and the corresponding label. So why this feature, the image file is classified as 5. So it extracts the features. It extracts the features and it maps to the label. Okay, so it will go through all the images and try to understand the hidden patterns. So once training is done and model has gone through the complete set of images, and we can use the model to predict the new set of images or unseen set of images. Okay. So now the training is going on. So it goes through all the samples batch wise. Okay, so this is the simple CNN model which we developed in Keras. So once that is done, we look into uh, passion analyst based CNN. And then, as one of the participants asked in the last session, how we can visualize what the model learned. So that also we can do. So with these three demos, after that we can go for a break. Okay, so training is done. So training is going on. So while it is running, we have a small break for the offline participants. So tea is there. So please have a tea. Okay, online participants can relax away.